Hello. So this time I would like to address the question of what is a mathematical proof? Well, we have seen proofs in textbooks, in articles, and the like, but when we are asked to produce a proof, sometimes we are encountered with a problem that we don't even know how to start because perhaps we don't know what it is. So let's start with a definition, which of course may change over time, over the course of your mathematical career to some extent. And we'll take it from there, and then we'll provide some examples of what would be an acceptable mathematical proof, okay, along with some types. So I'll start with this. So a mathematical proof let's say this is a definition, or at least an attempt, is a step-by-step demonstration of the truth of a mathematical statement. The important part is here the step-by-step. Let me put it down so that we can decompose this a little bit more. It consists of a finite sequence of arguments starting with explicitly stated assumptions or premises. That's another way to name them. Each subsequent argument follows logically from earlier ones. Well, how so? Well, using mathematical principles, axioms, definitions, or previously proven results. The proof finishes or culminates in an argument establishing the desired conclusion. Okay, and this is just providing undeniable evidence of the statement's validity. Okay, so let me start with an example. So something very concrete so that we can have our hands on. Okay. Consider the following statement, mathematical statement. The square of an even integer is even. Okay, I'm going to reformulate the statement in such a way so that we can see the implicit assumptions and the conclusion that we want to derive. Okay, so I will write it in an equivalent form. What will be that? Well, something along these lines. For each integer x, if x is even, then x squared is even. So now we're just using additionally some variables and some mathematical notation to help us in the process. Okay, so how do we start? Well, this will be the proof. the first one will be the assumption, right? So we'll say, let x be an even integer. Okay. So secondly, I'm going to bring a definition associated with this. What does it mean to be even? Well, it means that there exists an integer k such that x is equal to 2 times k. Just another way of saying that x is even. Okay. So now, some principles we're going to bring here. X squared, well, substitution, it's going to be 2k squared, which in turn is 4k squared, which I can decompose as 2 times 2k squared. Well, I'm going to state something here. 2k squared is an integer, which means that there is an integer, so that's when I multiply it to 2, it gives me x squared. That means that x squared is even. The conclusion is that indeed x squared is even. Now, this is an example of what we call a direct proof. And with this, I'll finish today, because on subsequent videos, I'm going to provide examples of other types of proofs. The one that I'm just stated here is the most common one, which would be a direct proof. Why is it called direct? Well, because we can see we have a sense of direction from the assumption to the conclusion. But there are other types of proofs, which we're going to explore in subsequent videos. Take care, and I'll see you next time.